Hi guys, hi again. In the last exercise, we have seen a very simple example of fine tuning where we took a very simple use case of creating a file, uploading it to OpenAI, training it, and then using it. So it's going to be exactly the same steps this time. It's going to be preparing the data set, uploading the files, creating a fine-tuning job, and then using the fine-tuned model for a given case. But today we are going to have a level up, and we're going to take a real life project where we would be downloading a file from a real use case. We're going to go to philosophy stack exchange, so it's a stack overflow for philosophy. Basically, we're going to download all the question answer data set. We're going to clean up the data using Python pandas. We're going to pre-process the data to bring it into a format that we really want, delete unwanted stuff, maybe unwanted rows, putting it into the right format, and then filtering it out because the data set is so huge, and then maybe it's going to be very very costly for our project. So we're going to filter out and reduce the number of rows that we're going to use it for our project, and then we estimate the cost that would be really required, or that's going to be uh, we will be charged against. So let's go directly into the project and do these steps one by one again. Okay, so let's go directly to the tutorial. As we said, as part of prepare the data set, we first have to get the file. Here is the file that has been downloaded from StackExchange. It's a philosophy.stackexchange.com, and it's all question answers basically. The file comes in as an XML file where you can see it's a huge file, around 180 MB or so, even more, and it has 67,480 plus rows. So truly huge file, and let's use that one basically for our tutorial now. Okay, here we get the file, we read the XML and then convert it into a data frame. Just to see, the file is in one of the folder, and we then import it into pandas data frame. If you just use the normal read XML, this basically uses the parser as LXML, and if the file is huge, I think if the file is more than 20 or 25 MB, then it doesn't work. It gives you huge file something error. But let's not get into all that. What you can do is use parser as etree, and I think it can also read huge files. The other way is read XML file row by row and then convert into data frame basically. So let's go ahead and read it into data frame. Oh, the data frame. And this is our raw data frame. This is how it looks like. So we have multiple columns which has different meanings to it, and yeah, we have post type IDs, we have answer IDs, we have some creation dates, a lot of columns that we may not be requiring. So this in the part 2, then we would do a lot of cleaning of the whole data frame. So now that the data is in our data frame, let's clean it then. We'll just see how does the data frame looks like. Yeah, it has 67,480 rows, and yeah, it doesn't have any other statistical meaningful information for now. We see what columns does it has. Yeah, there are multiple columns. Of course, it carries a lot of meaningful information, but the use case that we have in our hand for now, there are only few columns which we would be needing. So it's mostly the post ID, what kind of or what type of post it is, whether it's a comment or a question or an answer or an user information and things like that. The body, the text, title, mostly title is for the question. We'll see when we look at the data frame. And then we have something called as parent ID. I'll explain it to you at a later point of time. So we drop all other columns. This is not a very good practice. I mean, we can just let it be there, but I know for a fact that we wouldn't be requiring them. So I'll just replace, or I'll drop them in place equal to true. That means I don't have to assign it to another data frame. And then I'll just rename the columns. And okay, so here is my, let's say, cleaned up data frame where we have post ID, we have post type ID, we have the body of the post, we have the title, and we have post parent ID. So it's very intelligently made data structure or table. So if you see, there are different types. So if I look at very clearly, when I say post type is 1, that means it's a question. When its post type is equal to 2, it's an answer. Answer to which question? And that is been mentioned in post parent ID. So basically row or post ID 4 is answer to the question that is mentioned in post ID 1. So that's what it means. And now we just really intelligently want to rearrange, or we want to join data frame to itself. Basically, on the left hand side we want to have question data frame, on the right hand side we want to have answer data frame, and we want to connect them by post ID with post parent ID. So let's do that. Yeah, so I say question data frame wherever there is a post ID is equal to 1, we want them to be in question data frame, and wherever we have post type is ID is equal to 2, we put it into answer data frame, and then we merge them on post ID on the left side and post parent ID on the right side. Okay, let's have a look at our merged data frame. And here it is. So let's say where we have a question, post ID is equal to 1, and answer, this is its answer basically. So question 1 has 1, 2, 3, 4, 5, or even more. I am just let me take 10 rows. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, we have some. Let's try to take 25 just to see that we have. Okay, so we have 22 answers to question number 1 basically, and then question number 3 has multiple answers, but we'll see it at later point of time. But most important thing is our join was kind of quite correct. So for example, let's try to read. This is the question, this is the title of the question, this is kind of an answer. So looks good. Yeah, and then parent answer is equal to 1. Okay, let me go back again just to not occupy too much of space. And again, I don't need all the columns that was created with prefix or postfix, yeah, suffix. We just need few columns. we're gonna have title, we're gonna have question, and we're gonna have answer. Here I see lot of HTML tags and doesn't really look good. So what we can do is, as part of the cleanup, we can convert HTML tags to normal text, and such a complex thing can be done with few lines of code thanks to Beautiful Soap. Yeah, it's just basically one line of code, Beautiful Soap, and then convert it into text using getText. So I'll just define a function and I'll apply this function on both question and answer basically. Okay, done. Let's see how does our title, question, and answer look like. So wow, that looks quite clean, neat. I believe from a cleaning perspective we are quite good here. I believe we are quite ready for next step. Maybe the next step is, then this is again, I look at as one single question. No, it has a title and subtitle or description. So not everybody will do that, but for our case, because in our case, for fine-tuned training, we can just give two parameters, right? Question and answer, or context as user and context as agent. So instead of sending 3 columns, we can only send 2 columns. So let's combine title with body question, and then answer stays as answer then. So we just concatenated title with a question with 2 lines, 2 new lines or blank lines in between, and this is basically our question and this is basically answer. Yeah, so kind of our data preparation is almost done. But as I said, this file is quite big. Let me just see how big the file is. Dot describe. Yeah, it has 46,000 rows. Each rows has, I think, thousands of characters. So if I calculated, in the background, it has 28 million tokens, and if I upload that all to train our model, it would cost me around $800. So as I said, I'm a hobbyist. I will not be able to afford that. If there is any philosophy professor who are working on artificial intelligence or generative AI for philosophy, you're welcome to sponsor, and I can do something for you guys. But for our use case today, I'll just use maybe maximum 200 or 500 rows, and then we'll play along. So even though our data frame is ready, we would do some kind of filtering. Okay, the data is in data frames now, and then we want to take it into JSONL file with some kind of filtering and some formatting. So what we're going to say is the role is system, and the content is we're going to give an user prompt or custom instructions, and then we're going to have user content, basically nothing but our question, and then we're going to have assistants. The content are going to be the answer, and this data we're going to feed to train, so that it understands what kind of questions, what kind of answer it is, and then it can be used to train and then learn. Okay, we put it into a specific message format. That's the function I have written, small functions. So what I have done is we are going to have 2 data frames or 2 files basically. One we're going to use it for training, which I think we should use it close to around 1000 rows, let's say 1000 rows, and then we do some validation using let's say 100, or yeah, 1100 rows. Yeah, uh, let's say take 100 rows for validation. Okay, just to see how does it look like. Yeah, so each row kind of becomes a message. Okay, message, content, system. Where is it? Role, user, contents, role, assistant, contents. Okay, looks okay to me. Yeah, let's do the validation data, and then let's save these files into JSON L. So we are going to have two files basically, training file, and then we're going to have a validation file. Okay. Yeah, everything is written on a separate line, so that looks good. Okay, this step is optional. We just want to count how big the file is, so that you know how big the how much it's going to cost. So there is something called a tick token, which is used basically to count the tokens. The encoding that is normally used for GPT 3.5 or even 4 is CL100K base. And price, it's already there on their webpage. Training 1000 tokens is $0.08, I think, 0.8 rappen, or it's not rappen, it's cents. So yeah, we just normally use the formula to see how much would it cost me. So 1000 rows would be close to let's say 52 or 529,000 tokens, and we're gonna have 3 epochs, so that would be into 3 basically. So it would cost around $12, which is too much for me, but uh, okay, I can spend that much amount to showcase what I really want to show it here. Okay, and then of course the last part would be to train GPT model and use it. So let's go for it. Then of course you would need your OpenAI key, and then we upload the file. We upload two files, one as a training file and the other one as a validation file. Each one of them will have its own IDs basically, which we have to use as a reference when we train them. Okay, we just uploaded the file, hopefully successfully. These are the IDs, and we'll just look at its status. Okay, the status is uploaded. As we discussed last time, it will go through some processing, and then the final status would be processed. That's only when we can use the file for fine tuning. Okay, um, there are multiple APIs given. If you, for example, the file is not uploaded correctly or the work for the file is done, you can basically delete it. I have not seen anywhere any charges related to the disk space occupied by file or by model. I'm pretty sure these are negligible amounts. That's why OpenAPI has never mentioned them. But if you look at a huge files, there would be some cost occurring at a later point of time. So it's better if you are done with the file processing and your work, it's better to delete files as well as the models. Okay, so file processing doesn't take too long. It's a small file, I think few MBs. So if you see, I'm pretty sure that validation ID is WIS. It's processed, and then of course this is the one with 1000 rows. Yeah, it will take some time to process. So let's wait for it. Yeah, I think I'll pause the video and then I'll come back once this is processed. Okay, you can see the file is processed now. Um, that means we can go for the next step. The next step is as simple as it can be. It's calling an API with multiple parameters. Training file is equal to, we'll have to give an ID, we'll have to give an ID of a file. For validation, the model that we're gonna be doing fine tuning on. As of now, it's only GPT 3.5 Turbo. Maybe at a later point of time, we're gonna get model GPT 4. You can suffix the name of the model with a particular string basically. So yeah, here I'm using philosophy exchange. I wanted to use philosophy underscore exchange of StackExchange, but it allows only 18 characters max. So yeah, for the time being, I put it as philosophy, and then we can give hyperparameters. So as of now, there is only one hyperparameter called as number of epochs. Uh, yeah, so the total number of tokens into 3 would be my cost. So I want to keep the cost as much less as possible. So let me put it as just one epoch. And let's see how do we go about it. So the job has been submitted, and then we can just look at the status of our fine-tuning process. Historically, I have seen it takes much long time, maybe 5 minutes, 10 minutes, depending upon how big your file is and how much time it's going to take. So for the time being, then I'll pause um, and then come back to it at later point of time. Meanwhile, OpenAI has given a very nice UI on their mm, platform.openai.com/fine-tuning. Um, let's see how does it look like during the process. Or you can also call uh, the, let's say, events that are part of this particular fine tuning. So let me see, do we get anything? Yeah, so here it says, yeah, that's the job ID basically, and fine tuning job has started. So let's go and see how it looks like on UI. So here we are on platform.openai.com, their UI. So we have overview, and they have now given you a tab called as fine tuning. If you come here, you'll see all the models that you have been using for fine tuning. And this is my last job that I have submitted for fine tuning. So it's exactly all the details that we got. Yeah, it's the job ID, when was it created, how many epochs it would be running for, which files it has used for what purpose, for training and for validation, and then I believe these are the steps. Under the metrics, I think it will just show you the details of every step it has done. Again, I'll have to see the calculations of how does it divide. I think each row becomes one step. uh, I don't know. I'll have to figure it out. I have not gone too much deep into. So one epoch is basically going to be 1000 steps for me, because my file has 1000 rows in it. Yeah, it's, as I said, it's going to take too long time. So I'll be pausing a video here now, and then I'll resume once either we are somewhere in between during the training or at end of the training. So this is just an intermediate status update. Basically, I started around 6:30 Central Europe time, and then it ran for almost 3 hours. The job failed because of some internal error. I don't know what does that mean. And then it restarted the job and looks quite okay now after it's restarted. So it has run, let's say, 100 steps every 5 or 4 minutes. Um, and we can already see some oscillation in validation, but overall the graph is it's going down, so which is already a good thing. And training losses is continuous decrease. That's also a good thing. So let's wait for another few minutes for completion of 1,000 steps, and then we can proceed with our next part. Okay, so we can see that model is training is completed with 1,000 steps. Let's now use our fine-tuned model. So what will I do is I'll take one question from my 60,000 45,000 questions, and then would ask the same question to both base model as well as our fine-tuned model, and do a comparison side by side, to see if there are any differences, and you can see it for yourself basically. So there should be little bit increased more sense. It should have better wordings, more philosophical. um, yeah, that's what I can say. So the emphasis on the whole exercise here was to understand the process, the buts and ifs, or some issues that we normally face when we walk through the real life problems, and hope we could solve at least some of them here. I hope you can take at least one good lesson and put it back in your own exercises, and you will be encouraged to do something more. Let me know if I can be of any help. Thank you guys. Ciao.